Okay, so again, the goal is we have gone through about the first 26 chapters of this book. And now I'm going back and looking at some of the code examples. And we'll see how far we can get today. And then, like I said, we'll start at 3:30 on Thursday and we'll pick it up from there. But the idea is by the end of the period on Thursday, we'll be to that point. All right. So, like I said, hopefully we can start looking at some GUI stuff next week, and then, as mentioned, create the same tip calculator that we're working on in the other class. And like I said, I think that's a good exercise because it shows you some of the things that are the same yet different between them. All right. Okay. Now they come in here and the chapter is on arrays. This is not an array. Right there, that's not an array. That is creating three different data objects. But then they say, let's create an array that contains all three of these. The key thing to realize here, because we've talked about this is NS array, which means once you create that array, you cannot change it. If you want to be able to create an array and add to it or remove from it, it has to be NS mutable array. All right, we talked about that before. And what you'll see as we get on in here is we'll talk about sets and we'll talk about dictionaries, and all of them are immutable. So if you want a mutable dictionary, you've got to use NS mutable dictionary. If you want a mutable set, you've got to use NS mutable set, etc. So do you want to be able to change it or not? And as always, it depends on what it's being used for. If you're using an array literally as like a table where it's not going to change, you can set it and forget it. Then an NS array is better. All right? But if you know you're going to have constant activity on it, you'd want to be able to do an NS mutable array. And once you start using it, as you see in here, looks that line, these two lines that are right here in the blue one and the one under it, looks very similar to the way we worked with arrays in the past. Not the printing with this, but I mean this. The name of the array, our bracket, then the index number, and they start at 0, just like we've looked at in other languages before. All right. Notice it's not length here because that's how many elements, so arrays have a built-in thing called count. Why is that important? Well, that could be important because remember that if we were going to be iterating through this array and we wanted to use a regular for loop, we could use that count variable to figure out just exactly how many elements were in the array as an example. And, I should mention this. Hopefully what I'm about to say, it's like if I say this and you go, well, duh, that's a good thing. All right, but if I do something like this, and we've got this date list count. All right. So let's say that I'm writing a for loop. And I'm just going to keep this simple. So I write something like for I equals 0, I less than I plus plus. Okay, so I'm gonna leave that one there, and then I'm gonna rewrite it. And there's a reason for doing this because I want to just try to hopefully emphasize a point. So I'm gonna say here int count equals now. You're all smart enough that you realize there's more typing in this one than there is in this one. You all realize that. I get it. That said, tell me, not Bob, somebody else, tell me, why is the first one better than the second one? And it is. Why is writing this, even though it's more typing, why is writing that better than writing this? It's not a trick question. Okay, well, I guess that's an offshoot of it, but there's a more fundamental reason. Even more fundamental than that. When you do this, it has to figure that out every time. So what if there's a million elements in there? It's got to literally do the calculation a million times. Here, it does it once, and it plugs the value in there. Does that make sense? Those are the kind of things as a programmer, especially when you're talking about how you can save time If you're working on a very real-time intensive type of program and you want to look to save time, that's the kind of thing you'd be looking at. All right, it just makes sense. You literally should never be doing a calculation inside of a loop like this. All right. I understand what you're saying. I still say that if you hook them up to the clock, this should run faster than this one should. All right. And that's why I say, because to me, when I always look at it this way, okay, I got an email from Diane Jett. Diane Jett is now the Blackhawk, the person who's taken over for Darian. So she's the counselor for IT people. She wanted to know. She wanted to come in and talk to classes. So I wrote back to her and I said, yeah, you can come and talk to my first year classes on Monday, Wednesday, and I gave her 2 times. Well, I thought she'd choose one or the other, but she chose both. That's fine. I think she actually wanted to come in and talk to you guys, but I couldn't figure out why. You know, hopefully every one of you will be graduating in May. But the point is, before you go out the door, if there's these little, I wouldn't know if you'd call this a nugget, but it's just the kind of thing that's meant to spark you thinking about stuff like this. All right, because to me, that's one of the things that distinguishes a programmer from a good programmer. All right, and some people will tell you, and Bob might be right, depending on how the compiler does this, it may only do it once. But in most languages, when you've got something along these lines, in most languages, it's going to call that routine every time. Now, if it's a small array, who cares? Yeah, there's three elements in this array, so big, hairy deal. But a lot of times as you start going on, I can tell you about code, and you probably can too. I like I said, I remember code that I started writing when I was at AT&T that I came back and looked at it years later that people had added to it. And I literally set up my functions so they'd be 20 or 30 lines long. They were now 300 or 400 lines long. And where you had something like this, where you might have had only a few dates like we have down here, now there was a whole calendar full of dates. And stuff happens over time. So the idea is you write it right to begin with, because you don't want to sit there and think, well, somebody will fix it later. No, they won't. All right. Yeah. Okay. Mm-hmm. Yeah. Right. Well, and it was done with good intentions, right? So, all right. So it says you sent the data list to magic count. If you want to find out what count does, it says you could go to the NS Dates classes reference page, but there's a quicker way. So remember this. If you hold down on the option key for when they have count in here, so if you hold down on it and you click on it, all right, you know what that option key is? That's a little infinity symbol. So if you hold down on that and you click, all right, you can get quick help. It's not as extensive as stuff we've seen before, so there's not as much here, but sometimes that's all you're looking for. So they come back in and they look at some of the quick help for NS Array as an example. So they run the same thing on here so you can see. And it is nice because, again, sometimes what you want to know, the reason that you use this is, okay, I want to call this method. I know what it is. I don't know much about it, so I key in the method. And then I option click on it, and I'm told what kind of, how many parameters it requires and what those types of parameters are. All right, so it's just a little quick, nice thing to have. You might never use it, but you might end up using a lot too. All right, and this is kind of what we talked about before. That as far as using that. Remember, if you do, you said we had 3 elements in the array, so they'd be 0, 1, and 2. So if you decide that you want to go outside of the array, you can do that, but the program will crash. All right. Then they go through and they iterate through an array. We've talked about this. That's just using a regular for loop. Again, notice what they've done there. Date count. Kind of just what I mentioned to you before. All right. And there's also that fast enumeration. These are the kind of things as a programmer you should get used to using. Virtually every programming language has a for each or a for in or a for something. We saw this in Java. We saw this in PHP. Now, normally when you're using one of these loops, they're known as an enumeration or usually as an iteration loop. So the idea is when you use these kind of loops, you can't change you can't change the values of the variables inside. Did you hear what I said? It's designed to work through a loop. So if you want to print out every entry, this is faster than using a for loop. It's not only less code, it should inherently run faster than writing it that way. I guess right up above it. All right, I've already mentioned to you the mutable array, so hopefully again that's not, add to it, remove from it. All right, and it looks a little weird. Add object. So what are they doing? They're adding 2 dates to the array. All right. Now, notice that adds it, but it adds it to the end. I can say insert object, and I can tell it at index, so I can tell it where I want it to be inserted. By default, it goes to the end, but it doesn't have to be there. Notice here we did it at index 0, so it becomes the new first object in the array. The other ones will move down accordingly then. All right. And remove object at index. Again, as I said, you may not agree with this, but it's in their documentation. They say in places in there, we purposely named it like this because we wanted it to be very intuitive. So when you looked at it, the idea was you would be able to figure out what it is we're trying to do. The good news is it makes your code more self-documenting. The bad news is it's more to type. But it's not real bad news is because typically, again, you'll bring down some kind of IntelliSense where you'll be able to choose it. All right. Then they mention if you still want to use the old-fashioned type of array, that's how you used to do it. You used array with objects. That is creating an array. You can still do that. It's not deprecated. You can still use it. But if you do it this way, like this, with an NS array with objects, then you have to put nil at the end. That signifies it's like putting the \0 that we put on the end of a string. It's signifying the end of the array. If you leave it off, it says you'll at least get a compiler warning. When I tried to leave it off, it gave me a warning, but then when I ran the program, it did crash it. All right? And again, if you say, I don't remember how to use that, well, then if you type in this line and you don't remember that, you should be able to, in Xcode, option, right mouse click on it, and it should show you that in there, in the help. All right, then we went in and started looking at our first classes. Now remember, because this is where it started to change. And this doesn't matter if it's GUI or non-GUI. We were talking about creating another file. Remember that every single time you create a class in this language, it must subclass something. It must extend something. If you're not sure what it extends, you just have it extend to the default NS object. What will happen is as you build more and more classes and you click the down arrow, so if I created a class and then created another class, I'd start seeing a bunch of them in this list, if not all of them. All right? And you can extend from your classes or from an existing class. All right? We talked about this. My hope is by now looking at this, everything that's in there makes sense to you. There's nothing hidden, nothing funny, nothing funky, etc. It all makes sense. All right? We talked about why you use the underscores, etc. And even though you don't have to, you should now. So that was the header file. This is the this is the rest of the header file. You should be able to read that, everything that's there in blue. And that should all make sense to you now. You should understand that the minus sign means that it's an instance method, that the parens after the minus sign is the return type, and that any time in there you've got a colon followed by something at the end, that's the parameter that you're passing in. That should all make sense to you now. You should know that when you get to the .m file, the first thing you're always going to do in your .m file is you're always going to import your .h file. All right, remember that's kind of your window into the .m file. Okay? And the stuff that's in here, we talked about this before. This stuff is almost the same way we did it in Java, the same way we did it in C, Not exactly, but I mean, it's the old setters and getters type of thing. Remember, it is legal in this language if you want to. If up above here, when we did this, you don't have to put, right here, we didn't have to put the underscore in there. We could have just called it height in meters. And we could have called this height in meters. So you could have two different things. Literally, you could have said this could have been called this, and you could have left that off and have it say return height in meters. And the system is smart enough to know that you're using the same thing as both a variable and the name of a method. All right. Most books will recommend you do it the way that he's shown it here, but you don't have to do that. Again, my hope is that you can look at this and everything that's in here makes sense to you. All right. There is a math object, so you didn't have to do that. There's a math. I think there's like the POW object, like I believe that is in C. I don't remember, but I know there's a math object in here, so you didn't have to do it this way. Okay. You didn't have to say height times height in this example. Because we looked at it before. You should understand all this. Remember, he put B and R there. And it's funny, I asked when I was talking to Eric today, I said, do you have your students, when they asked to put that class prefix in there, do you have them put it in? He said, not in the first semester, but they do it in the second semester. And I said, why? He said, they've already got enough. They're already screwed up enough in the first semester. All right, he said, it's just one less thing they have to worry about then. But the key thing, and I mentioned this to you before, is Apple says if you're going to use one, make it at least 3 characters and never make it 2. Because if it's 2 characters, that's sending a subliminal message to the system that it's a system prefix. All Macs, like the NS stuff, NS array, etc., those are prefixes. All right. So you should understand this. And we're going to get to it in just a couple minutes, but you should understand that what are we doing here? Well, right here we're creating a Mikey object, right? Right there. And what are we doing here? Well, we're setting the Mikey object's weight, and we're setting the Mikey object's height. And as you'll see in a couple more pages, we could do this using the dot structure also. One is not advantageous to the other. In other words, doing it this way as opposed to saying Mikey dot set weight in kilos equal 96 won't run faster or slower either way. I would say that probably more of a pure C programmer would probably do it that way. Whereas if somebody was learning this as their first language, they'd probably just do it this way. This is more reminiscent of the way you typically call things and the way it typically looks and the way it's typically shown in the documentation. All right. Since we're creating simple variables here and here, when we NS log them, %F, %D, just like we had in C. Okay. And what we'll get to later is there are also there's an NS number. There are number objects that you can use too. All right. So I've already kind of talked about this, the accessor and the naming conventions, etc. So you've seen all that stuff. All right. This is something right here. Remember, self, for lack of better words, in this language replaces the word this. And you have to get a familiarity with it because it's more powerful than the word this is in Java. All right, there's more stuff that you can do with it. Inside any method, you have access to the explicit local variable self. It's a pointer to the object that's running the method. It's used when a method wants to send a message to itself. And there may be a reason for doing that. All right. So notice what they've done here. They've got here body mass index. This says return weight return weight divided by height in meters times height in meters. All right, and they're replacing that with float h equals self dot height or self height in meters, and then return self height in kilos times h times h. That h that you see there is this h here. Now, you might look at that and say that's harder to read. All right, but this actually typifies more of what's really going on behind the scenes, under the covers, whatever you want to say. So it's not important that you do it one way or the other. It's that you realize the importance of the fact that you can do it either way. That's what matters. There's the prefixes. We already talked about those. I've got this in here. So if you want to look at this, not necessarily that you have to look at it right at this second, But just so you see that that's in there also. That's a that's a more of a complex example. I think that was 17. No, must have been 18. Yep. You'll notice that the programs are starting to get not a lot bigger, but a little bit bigger. So what are we doing? Well, we're coming in here and we're creating 3 stock objects. All right. Those are really bad names. We probably could have, instead of stock 1, 2, and 3, we should have called them something like, Google, Apple, Microsoft, whatever. But you can see what we're doing in here. And then we're calling set number of shares, set purchase price, set current share price, etc. And then you can do some math with them. You can iterate your way through them. You should, and I'm just about finished, but you don't have to do it right now, but you should take some time, go over this, and make sure the program makes sense to you. All right? That one thing you got to realize is there's not a lot in this. There's not a lot in this book that's really new other than syntax. That much of the stuff that's in here we've already talked about. All right? I'm going to end with this because this is a good spot to finish with the properties. Remember that once we start using properties, that using these 2 lines, these 2 right there, means we remove those 6 lines that you see inside of the .h file, plus what they remove is inside of your .m file, all of your getters and setters. Sometimes you'll see what this does by using properties. It synthesizes for you. It sets stuff up behind the scenes. All right? So literally what happens is you see how much smaller, because your whole interface now, just pretend I had the @end at the end of this. All right? That's your whole interface right there with the @end. That's it. And then your whole .m file, your whole implementation is that line there and then this. So you can see how much it shrinks. So the more variables that you have, the more code that you're going to save. And that's what the author, I believe that's exactly the point he's trying to bring across in here. All right. And we talked a little bit about this. And again, if you don't know that much about threading, basically it's the ability for a program to do more than one thing at a time. All right. You hear about, when people talk about, oh yeah, you're a good multitasker. That's kind of having a program multitask. All right. And you can argue with me saying it's really not because it's doing some stuff in the back. It doesn't matter. All right. But basically what you're saying is if I'm not going to be worrying about threading and multi-threading, we'll set it to non-atomic. The problem is if you don't set it, it defaults to atomic, and the program will run slower at atomic than it does with running it non-atomic because there's some reconciliation and some stuff that has to go on behind the scenes. All right. And finally, they talked about that dot notation, and we talked about this. Objective-C programmers call accessor methods a lot. When properties were introduced, Apple introduced a shorthand dot notation for calling these accessors. Most prefer that because it looks C-like. And a lot of times, well, how do I know if I can use that or when I can use that? As opposed to, I don't want to use this one right here. I don't want to use that one that's crossed out there. I don't want to use that one. I want to use that one. How do I know? Well, instead of typing it like this, you type in the name of the object dot, and then the IntelliSense should kick in and tell you what you have available to you, if it makes sense in that context. And then you'll know whether or not you'll be able to use it. So again, they say these 2 mean the same, these 2 mean the same. And there really, again, isn't so much an advantage of one versus the other. All right? So Thursday, I'd like to look at more code and not talk that much. So Thursday, we'll go over the rest of those chapters that we haven't touched on so far. All right? I know it's a little early, but my voice is going.